Hi, I'm doing a re-recording of session 3 just because during the live session in Zoom, I didn't have enough time to cover all that I had planned because we had a hard stop after 2 hours. I also have some issues with the autocomplete and cursor, which I'm now trying to address by disabling that. So let's get it. So you know that we have 3 people in this Basecamp. This is Basecamp 13. I'm the teacher, David Barreto. Then you have Zutun Cheng as the Master of Ceremonies, and then Truth as the teacher assistant. We have this scoring system for this Basecamp. You get 20 points by answering all the quizzes. The quiz for this session was shared on Discord as a Google form. Then you have actually 2 homeworks. One of them is to just do the live coding with me starting session 4, so starting next week. And then the other homework is to complete Starlinks. And you have the link here, starlinks.app, where you can learn all about Cairo. We have some graduation criteria, so 3 levels for completion of Basecamp. You can either be an attendee if you only attend at least 25% of the classes, live classes, or watching the recordings on Zoom. You can become a graduate if you attend at least half of the live classes and score at least 30 points out of 60 that you can collect. And then there's a higher tier for graduation, graduate with honors, where you will have to score at least 48 points out of 60 to get that badge. Questions? Obviously, this is a recorded session. It's not on Zoom, but any question, you can just go to Discord, answer there. I'm there just reviewing questions, Truth as well, but also your peers are more than welcome to help you with the questions as well. This is the 3rd section of the cohort, so we're talking about Cairo language. We started with Bitcoin and Ethereum, was an optional session as an introduction to blockchain. Then we move on to talk about Starknet and Layer 2s. Today, talking about Cairo as a language, and just Cairo for general purpose programming language, not for smart contracts, because that's going to be the topic for session 4, Cairo smart contracts. Then we're going to talk about how to do testing with Foundry, in this case, a Starknet Foundry. And the last session is going to be about how to build a web UI for your Starknet application with Scaffold. Topics for today. I'm going to quickly show you how to do the installation with Starkup so you can bring all those dependencies that you need to create Cairo applications locally. I'm just going to show you, I'm not going to use that myself because my preference is always to use Docker, just because I like the encapsulation and the control that it gives you about which dependency to use, but you're welcome to use either one. I'm not going to do much configuring for Cursor this time because the AI got actually in the way. It was too noisy for my taste. But then I'm going to show you how to create a Cairo project with Scarb. I'm not going to jump into the execute, proof, and verify. I did that in session 1 quickly. But this is just, I think, beyond what I want to show today. I just want to focus on the code itself and Cairo the language. So for Cairo the language, we're going to talk about fields, functions, integers. We're not going to have a break in the recording. Then we're going to talk about casting, options, and enums, mutable, snapshot, references, and finally traits, constraints, and arrays. And the quiz, as I mentioned, was shared as a link on Discord. So to recap session 2, when we talk about Starknet and other layer 2s, I mentioned that there are 2 types of rollups. You have the optimistic rollups and the ZK rollups. And optimistic, you have something like Arbitrum, like Optimism, Base. And then for the ZK rollup family, you have Starknet, you have ZK Sync, you have Scroll, and many others. In my opinion, ZK rollups are more secure and cheaper to use. And this security comes from the fact that the network is verified every 5 to 8 hours, compared to optimistic rollup that is assumed that no one is cheating unless challenged. But also it's cheaper to use because it uses less data availability from Ethereum. It has to send less data to Ethereum for secure tracking of the state. Starknet, as I mentioned, is a ZK rollup and is based on ZK Starks, technology pioneered by Starkware, the company behind Starknet. Some of key issues of ZK Stark is that it doesn't require a trusted setup, which is a much higher security guarantee for the rollup. And also this technology is deemed to be post-quantum secure, so not even a quantum computer will be able to create a fake Stark proof that's going to pass as valid. To achieve all of that, Starknet actually has its own virtual machine. It's called the Cairo VM, or sometimes referred to the CVM. And this is in contrast to the EVM that many ZK rollups wants to follow. the Ethereum virtual machine. So this is a different type of virtual machine specifically made for Cairo and for validity proofs. And of course, that means that Starknet has its own programming language, Cairo, which we're going to learn today, which shares some similarities in syntax only with Rust. We also discussed that every wallet on a Starknet is actually a smart wallet, meaning that they implement this pattern called the account abstraction, where you can actually control how signatures are verified and things like multi-call as well. And finally, we mentioned the plans for Starknet to integrate with Bitcoin, either following 3 potential paths. One of them is using BitVM. Second was to use Collider VM, research also done by Starkware. And then finally, just native verification using OPCAT if that ever gets re-enabled on Bitcoin. Okay, now let's jump to the actual coding part. So I mentioned that you have 2 ways to install dependencies. One of them will be to use this project called Starkup, created by Software Mansion, which is the same company that developed Scarb, the package manager for Cairo. And the nice thing about this is just with a single command in the terminal, you install all these dependencies. Scarb, the package manager, the testing suite with Foundry, the local devnet, and many more things. The downside for me is that it installs all these dependencies globally. So it doesn't give you this fine control if you want to go into a project that maybe use some dependencies and then you jump in a different one, maybe lower dependencies. This is global dependencies, so all the projects that you work on, they need to use the same, which is nice when you get started. When you try to work in multiple repos like myself, it doesn't give you that fine level detail of control. One thing also to keep in mind is that when you install the recommended version, which is like the compatible version, right now it's giving you Scarb 2.11.4, which is lacking some of the improvements in performance that we got in the latest version, 2.12.0. So if you want to use the latest version of all the dependencies, you have to use this flag latest, basically using this command. It will give you the latest of all the dependencies, but there's no guarantee that they're compatible among themselves. But for this session, we only want to use Scarb, so I'm actually going to be using 2.12.0, but I'm going to use Docker. So if you use it this time and you use it this way and you install it with the Starkup, you don't need to use Docker, right? So use one path or the other one. So, but if you want to use Docker, like as my case, I'm going to show you how. Let me open now my terminal. Here we are. So first of all, I'm going to create a folder. Let's call it Basecamp, a folder. And I'm going to enter Basecamp. I'm going to open this with cursor. And I'm going to bring it here. You can use cursor, you can use VS Code. It's basically the same thing. One thing I'm going to do is I'm going to snooze the autocomplete because that's the thing that was annoying me the most. Let's snooze this for 3 hours. So while I'm teaching this, I don't get the same autocomplete noise I was getting all the time before. All right, so I have a completely empty project. So if you want to use Docker, first of all, you have to make sure that Docker is running on your machine. And in my case, it's running. Also make sure that you're giving enough resources for Docker to run, because Docker on macOS is a virtual machine. So you have to give it all the resources. I gave it all that I could give it: 8 cores, 24 gigabytes of RAM. So I'm never run out of memory, let's say. There's an update available, but I can do it later. Okay. So to be able to use Docker with cursor or with VS Code, the idea is that I'm able to relaunch a version of the IDE inside the container that has all these dependencies that I need, right? So I have this nice encapsulation. But for this to work, I need to make sure that I have one extension installed. And that extension is called dev containers. Dev containers, this one. So make sure you install this dependency either in cursor or in VS Code before we go to the next steps. Otherwise, it's not going to work. And this is what's going to allow the IDE to work in tandem with Docker without you having to know any line of Docker at all, like nothing in the command line. So once you have it installed, first step is to actually create a new file called dev.devcontainer.json. Oops, misspelled. Rename .json. Okay. So this being a JSON file, the first thing that we need to define is what's going to be the name of the container when we run it. Let's call this just Starkup Basecamp, right? Something easy to identify. Next thing that I need to know is, okay, which image we want to base the container on. So we could use the image key. And I actually published this image, and the one maintaining it is under the name Starkup Foundation. This is in Docker Hub /Starkup dev 2.12.0. I want to use the latest one, Starkup Foundation. Yeah. Next, I need to tell the IDE, say, okay, whenever you launch the IDE within the container, I want you to install by default 2 extensions. One is for the syntax highlighting of Cairo, and one for syntax highlighting of Mutable, which is the configuration file of Scarb. So to do that, I define the customizations. And because cursor is based on VS Code, it actually uses the same keyword. So configuring this VS Code is actually configuring cursor itself. I'm just going to tell which extensions to load. Extensions. And the first one I want to enable is one called Starkware Cairo 1. This actually has to be an array, not a bracket. Right. This is a syntax highlighter for Cairo, and then the syntax highlighter for Mutable is Tamasfe even better Mutable. Okay, so we have these 2 extensions. Okay, so now we have this configuration here. This is for dev container, so we need to have the extension running. The way to launch the IDE within the container will be to go to View, Command Palette, and in here you're gonna find this command, dev container rebuild and reopen in container. So I'm gonna click this, and this is gonna download the image, build it locally. Well, not build it, just download the image, and then launch an instance of cursor with those extensions that I defined install inside the container. So let's give it a try. All right. So now, as you can see in my terminal, I'm inside the container, no longer in my host OS. And if I do Scarb version, you see that I have 2.12.0 available inside this IDE that is inside the container. That's the only dependency I'm actually gonna need for this project. So because I have Scarb now, I'm able to use the Scarb IDE, the CLI, to create a new project that has some default files that you'll need for start working. So for that, you do Scarb init, and it's going to ask you, okay, which test runner do you want to use? Do you want to use Foundry test runner, or you want to use the default test runner for Cairo? I will go with Foundry if I were working on a smart contract, but because I just want to show you Cairo as a general purpose programming language, not for a smart contract, I'm going to use the default test runner. The syntax for both of them is the same. It's just Foundry gives you way more things that you can use for integration tests for smart contract. So I'm just going to go simple. So also the compilation is faster. So there you go. It creates a few files. Maybe the most important one is scarb.toml. And this file has a few things. First of all, it's very similar to what you will find in Rust with cargo.toml, which you define the package, and the default name of the package is the name of the folder. You can modify this, of course. This is going to be the version of your project that you can, just give me your 0.1.0 as a starting number. Then you have the edition. This is the prelude of Cairo that you want to be enabled without having to bring into scope multiple things. Essentially, use always the latest prelude available. You can see the list of preludes in the Cairo book, but this is the latest one that comes with Scarb. And then you can define multiple dependencies for your project. The only one that we have right now is the test runner, the Cairo test that we selected when we created the package. That's the only one that we need right now. We're gonna bring another one later in the course. So, okay. And it also brings some example code, basically a Fibonacci code that I'm not gonna use. I'm just gonna remove this So we can create everything from scratch. And the first thing I'm gonna show you is actually field elements or fields. So let's create a new module or a new file called fields.cairo. Okay, so instead of printing values to the terminal and just check that it's actually the correct value, I'm gonna do something closer to test-driven development, where I'm gonna actually define some test cases and then build the code to pass those test cases, so I can show you all the things that you can do, and especially all the details about Cairo. So to define a collection of tests, in this case will be unit test, you need to use the attribute CFG test, and then define a module just beneath that. Let's call it module tests. So what this attribute is doing is basically telling, hey, anything that I put within this module is gonna belong just to the test suite of this module. So whenever I want to just compile the code of the module, you can safely ignore the test, so don't compile it. Only compile them if I want to run the test. So it's a way to do compilation in a much more performant way in when you have a bigger code base. So you can select which things to compile based on what you want to do. Inside the module, now you can define individual test cases with the attribute test. And then you define the test with a function. Let's call the first function, increase the font size just one more, okay. So the first thing that I want to showcase, if I manage to close the terminal, is gonna be implicit versus explicit types. So let's call it implicit versus explicit, and it is a function. So what I want to do in the function, you just define two types, which are essentially the same thing. Just one, let's say with the keyword let, you define a variable. I'm not gonna define a type, I'm just gonna say is equal to, let's say 5, right? Notice that even though I didn't define the type explicitly, the extension is actually telling me, okay, this is the type that the compiler is gonna infer from what you define here. So it's inferring felt 252. But if I want to be very explicit about the type, I can just do it myself. Just equals to 5. So it is exactly the same thing, and just to show you that it's exactly the same thing, we can do an assertion, and this is a way to actually do the test itself. So I'm gonna assert that A is equal to B, and those two things are equal only if they are of the same type and they have the same value. To check the test that it runs, let's clear this do Scarb test. It's gonna run all the tests that it can find on the project. So there you go. So it ran one test and it passed, right? The implicit versus explicit. So yes, as I'm showing here, this is the default type of Cairo, felt 252. Felt means field element, and a field element is kind of similar to an integer, but it has some different properties, especially how the arithmetic operations work, in particular division. Because in field arithmetic, you will always use the modulo for every type of computation. So you always want to wrap around in any operation, which is not what you would expect normally in your code, right? You don't like your balance wants to go a certain value to wrap around and go back to 0, right? That will be very unexpected. But in the field of mathematics, in the field of field elements, which is required for the Cairo CPU to execute, that is a normal property of how math works. So let me show you that. Let's do another test that is just about just simple mathematical operations. So let's create another test case. Let's call this one test arithmetic, or just test math, simple. And I'm just gonna define two variables and then do some computation with those two. Let's define A and B. Let's define the type explicitly. Let's say this is 4. And then say that has B and it's also failed, and this one is 2. So first operation that we're gonna test is addition. So if you do A plus B, that should be equals to 6, right? This is working fine. You can see that there's no the error so far. Let's try subtraction. Let's do an assert. Let's do B minus A, just to have a positive number. So this should be 2. Okay, this is working fine. Let's do now multiplication, which should also work no problem. A times B equals 8. Good, right? So far so good. If I try to run the test, this is all gonna work fine. Unless, oh, okay, there's one thing I forgot to change in the Scarb.toml because it's trying to calculate gas, but gas doesn't really make sense in this scenario because we're not writing a smart contract. So I'm gonna disable that gas calculation in my project, and I do that by defining a new property called Cairo, and in here just enable gas equals to false, right? So this is gonna take away that issue with the gas. We don't need it in this scenario. It is failing because, right, b minus a is not 2, it's minus 2. So actually, let me do that. I can either modify this a minus b. Okay, yes, so a minus b is actually 2, otherwise it was going to be minus 2. Let's try now to do a division. This is where the behavior of fails start to be counterintuitive to what you would expect from an integer. So if I try to do assert, is do a divided by b, you can see that normally this will be 0 because this is normally what's called an integer division. Wait, this would be 0? I don't know, this should be 2. Should be 2, normally. But it's still working, right? You can see that there's some warning here or some error. Trait has no implementation in context, failed to 52. That's because the integer division doesn't exist in felt. It only exists in unsigned integers and signed integers. So this is not going to work. That's problem number 1 for felts. An associated problem will be try to find the modulo or the remainder of a division, right? If I try to do assert a mod b, and this should be, normally this will be 0 for integers, right? Because this is going to be a perfect division, no remainder. But again, there's no implementation for felt. Felt is a very finicky data type that you need to know. If you want to use it, you really need to know in which situation you want to use it. Because normally what you want to use is just integers, unsigned integer and signed integers. So these two things not allowed with felts. That is issue number 1. The other issue that I mentioned is that felts or field elements, they just overflow. That is a normal part of the mathematics that they use. Let me show you that. Here another test here. Let's call this test now. Test overflow felt should panic. So normally you would expect if it tries to overflow that the execution will stop with an error. Hey, you cannot overflow, but you're gonna see that this doesn't happen. To test a panic scenario in a way that it passes the test, you use the attribute should panic. Okay. So let me define now. Just so you know, every operation with field elements, they're gonna be modulo a certain number, and that number is actually a very large prime number that requires 252 bits for storage. This number, this is something, it's just a curiosity of the language, is this. This is a very large prime number that wraps every computation in felt. So let's try to force this to overflow. Let's now get a variable, let's call it p divided by 10, just to take like a smaller number. And this is gonna be felt to 52, and its value is gonna be this value. I'm just gonna remove one decimal, the last one, so it fits into, because if I try to put the whole value, say, oh, it doesn't fit, right? This is just pushing the boundary of what you can store there. So let's get divided by 10. And then what I'm going to do, I'm just gonna try to multiply this by 100, right? So to guarantee that I'm trying to go over and see what happens. Okay, so if this were an unsigned integer, this should panic. This should not be possible because it's overflow, and it should panic. It should be caught here, so the test should pass normally. But you're gonna see that this fails, right? It fails because it is not panicking. It is allowing this computation to go ahead, and it's giving a result that is wrapping around this prime number going. It's actually giving back like a negative number. It's just the way field elements work. I just want to show you that. So I'm gonna ignore this test just to leave it here, but we know that this doesn't work, it's overflowing. Let me show you the other version of this is actually using an unsigned integer. So you can see that the overflow is actually controlled and prevented by panicking the execution. Panicking is just like erasing an error, basically. So I'm gonna repeat this. I'm gonna create a new test. This test should panic, right? Because we want to try the overflow. Let's call this test overflow U256, unsigned integer of 256 bit, should panic. So let's give it a try. So now what I'm gonna do, I'm gonna find a variable called max U256 of this type. And I'm gonna find what is the maximum value you can store in 256 bits. It's actually this. If you do the calculation, this is the maximum value you can store in that amount of bits. So I'm gonna put this as my value. You can see that it's allowed, it's all good. And I'm just gonna try to push it and go or multiply this by 100, right? Just to guarantee that I'm going over. So if this panics, meaning that if it prevents the overflow, this test should pass because I'm using this property, should panic. Let's give it a try. And it's working out. So this is proof that when you use an unsigned integer, at least the overflow is controlled. It would not happen, it will panic the execution and stop. There is actually one situation where it could be okay to use fails. That is the case of a short string. And a short string is, as the name implies, a string that is short only, maximum 31 ASCII characters. So let me show you how it works. Another test case. Let's call this test short string. And let's create the short string. So let's call the variable short string just to make it explicit that it's a fail so you know what I'm talking about. To define a short string, you have to use single quotes. If you use double quotes, it is not a short string. It's actually a byte array, which is different type. Notice that I can define strings and that is allowed. No issues. The warning here is that it's not being used. But notice that if I put more than 31 characters, error, right? Because a failed as a short string is basically, this turns into a single failed, into a numeric value. And the maximum amount of ASCII characters that you can fit in 252 bits is 31 ASCII characters. That is why that is the hard limit. So let's actually get something very small. Let's just letter A, okay? And to prove to you that it's actually just the ASCII value stored in this variable, we can do an assertion and get into the ASCII value of A. And the ASCII value is 97, sorry, short string. You go to an ASCII table, this is the value for the letter A. Let's give it a try. And it's passing, right? So proving that this is just a representation of an ASCII instead of a failed. But I mentioned that you can have something closer to a string, which is called a byte array, that now you don't have this limit in size. So let me show you how it works. It's called a test byte array. And now I'm gonna define a variable called byte array. Let's define the type as byte array, right? So we know it's no longer just a failed. And now, no limit of the size of this string, right? So now, benefit, you don't have a limit. Notice that I'm using now double quotes. Important, this is how you define a byte array instead of a short string. And you don't have a limit in size, right? You can just go on and it's all good, it's unlimited. And you can actually, I can do like a simple assertion, verifying, for example, the length of this array. So byte array, it's called the property length. And this is equal to, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 6, 7, 8, 9, 40, 1, 2, 3, 4, 5. Did I count correctly? 44? 44? There we go. 45. I'm not counting correctly. Let me put something smaller so it's simple. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So you can see you have some properties in the byte array, but the good thing is that you don't have any limit on size. The one limitation is that it doesn't support Unicode characters, only regular ASCII. So that's it for Felts. Felts, and the counterpart is byte array, and the fact that overflow protection is only guaranteed with unsigned integers and signed integers, not with Felts. Let's now go to their cousins, the one that I would recommend you to use instead of Felts. And that is, sorry, I'm going to functions first. Let me just do an overview of functions. So let me create a new file. It's called functions.cairo. And let's define this module, functions. So the name of the module must match the name of the file. That's how I can find it. If I open here my functions. So let's create a couple of simple functions. Let's create, for example, foo. In a function, you can define the return type with the arrow. So let's say that this return type is an unsigned integer of 32 bits. And let's say just 5. Notice if I don't define a semicolon at the end, it's just gonna return the value immediately, right? It's like an implicit return. So now this values is interpreted to be unsigned integer 32. You can call another function from a function, right? As you would expect. So let's define bar, and bar calls foo. If I don't put the semicolon, it's just gonna return the value that foo returns, which is 5. So these both return the same value. It's working. Let's define a third function. Now this time it is gonna do an explicit return. So in this case, you can actually use the return keyword, like any other languages, and says return 10. Notice that now I have to put the return. This is bus. Let's put a different name. Foo bar bus. So you have the option, right? You have an implicit return or you have an explicit return. You can also define arguments. Let's call this function double. And now this function expects one argument. It says X. You have to define always the type of the argument. And let's define a return value as well. Let's say this also U32. In this case, due to the calculation. Again, no semicolon, just to return the value implicitly. So let's do some simple assertions just to make sure that everything is working as expected. Again, we define our testing module with CFG test. Define the module tests. And now we define the different test cases. Now, these functions exist outside the scope of this module. To bring them into scope so I can reference them there inside the test module, I need to use the use statement or use keyword. And let's go one level up, super, and say bring everything. That's what it's doing. Just everything you find in the scope that is just above you, the super keyword, bring everything into this scope. So now I can reference it in my test. So for example, I can do a simple test here that says function test foo, and this one is simply going to just do an assertion that if I call foo, I get the value 5. Okay, and I can be more explicit. I can say the value 5 of type U32. Right, this is another syntax that you can see later, but normally this is fine. The compiler is able to infer the type of both sides of the equation. If this worked, should pass the test. Yes, it's passing. Let's do the test for bar. So function test bar. So very similar. I do another assertion. This time I'm gonna call bar, and bar should return also 5, right? Because it calls foo, and the value returned by foo returned by bar. So let's see if I save and I run, it passes. Let's test now the third function. Test bus, and bus now expects one argument to be passed. So sorry, no, it's not bus the one that expects an argument. It's just the one that has the explicit return statement. So let's do the assertion. We call bus, and bus is returning 10 if I'm not mistaken. close this one. Yes, constant. Okay, let's run the test suite. Yes, good. And finally, let's test the double function. Function test double. In this case, now do the assertion. And I'm gonna call double. Let's pass a value. Let's pass 5, for example, and this should return 10. Right? It's doubling the number. Run the test. Everything is working fine. So this is all about functions. Implicit return. You can call another function. You can define the return type, or you have to define the return type. You can define arguments, and you always have to define the type of the argument, and then that's it. Let's move on now to integers, which I was mentioning. There's like the cousin of the fields and the one that you usually want to use instead of fields. So let's create a new file. Checking my notes again. This file is going to be called wrong location here. Integers.cairo. Let's define the module here. Module integers. Okay. Let me open my reference. Cool. So we have two types of integers. We have unsigned integers and signed integers. So let me show you all of them in one function. Let's call this unsigned integers. So let's define the function A, let's say, is of type unsigned integer 8. This is the smallest number you can define for an integer, or the smallest type, only 8 bits. We can have B, and now the next value will be unsigned integer 16, and the max value you can store there will be 2 to the power of 16. That is the number. Then you have unsigned integer 32. That's the next level. Maximum value to store will be this one, 2 to the power of 32. Then you have D, and you can have U64. Maximum value is this one right here. Then we continue going up with U128, and the maximum value is this one. And then finally you have U256, which is the biggest type available, and that is the maximum number you can store in that type. Notice it's complaining because these variables are not being used, so you're gonna see a warning in the terminal if you run the test. To avoid this warning, just put a underscore before, just a way to signal that, you know, I don't plan to use these variables and it's fine. That's all it's doing, just keeping the compiler quiet, the lintern quiet. So that's all the types. You can do the same thing, obviously. You can define the type directly in the value itself. Let me show you what I mean. Let me copy this here. Let's put different numbers, G, H, I, J, K, and L. And now, instead of defining the type here, we can do this. This is also valid, okay? So just a different syntax that you can play with, but it has this exact same value to it. It's going to show you, you know, that you have both options available, 32, then here for U64, and 128. Finally, U256. Notice how the linter is very helpful, telling me that, hey, I know which type it is. It's as if you were defining the type this way. All right, two different syntax for defining the type. I normally prefer the first one, it's more explicit, but sometimes when I'm doing testing, I might use this as a way to do it, like, easier to read the test. Then you have an interesting new type, which is the not new, but it's common in other languages, usize. In the case of Cairo, let's call it _m, usize. And that just corresponds to U32 in Cairo. It's the same thing. So this is the maximum value you can store in usize. And of course, you can do it with the other syntax for defining the type, which is like this, right? Both things mean exactly the same thing as U32, usize. That is for unsigned integers. Now let's take a look at signed integers. Functions signed integers. Oops. And I'm just going to copy some code because it's easy to explain. So you have the same from 8 bits, 16, 32, 64, 128. The difference is now you can have negative numbers, right? And because now you have to split, like the half is going to be negative numbers, the other half is going to be positive numbers. The absolute number is actually lower. So this is the minimum number you can store, minus 128 up to 127. And then this is for I16, I32, I64, and I128. There is not I256. Like if I try to do this, it fails. Like, look, if I try to do this, it says this type doesn't exist. Okay, so important to keep in mind. U256 only exists in this world, not in the signed world. And in a similar way, you can define the type as a suffix of the literal, right? Like define it here at the end, same thing. One more time, you cannot go all the way to I256. That doesn't exist. And also what doesn't exist is size, I size, right? Like if I do M, let's put it before, I try to do I size, this doesn't exist, okay? It only exists for unsigned integers. So I'm gonna leave it here just as a reference. Oops. I'm gonna put here the final code. So these things, they don't exist. So a few changes or differences between unsigned integers and signed integers. Let's see a little bit of the mathematics of integers, so because we can compare it to what we did before with fields. So let's create the tests for this section. CFG test module tests. All right, first test that I want to do is I want to show all the basic math that you can do. So test basic uint math, okay? So in here, I'm gonna find two variables, A and B, both U8, so the smallest possible, and B also U8, let's say that is 5, okay, 3 and 5, U8. So now let's do some basic things like addition, subtraction, multiplication, division, remainder, modulo. So assert, let's do addition, A plus B. This is equal to 8, since we're working. Let's do now subtraction. Let's do B minus A. This should be equals to 2. This seems to be working. Let's do now multiplication. A times B. This should be 8. Again, all good. So now let's go to the two other operations that actually didn't work for fields, right? Which is division and remainder. So assert, let's do the division, B divided by A, right? So this is 1, right? Because this is an integer division. And if I try to do the remainder of that division, B remainder A or modulo A, we should get 2. And because these are unsigned integers, this operation should actually work. And something is not working out. A times B. Oh, wait a second, this is 15. Okay, yeah, I just had the wrong number there. But now this is what you expect, right? Division and modulo actually working. That's what I'm saying. Always default to using unsigned integers or signed integers depending on your use case. Normally for a smart contract, you almost always use unsigned integers. Let me show you now that another benefit of these integers is the overflow protection. So let's go on the test scenario where I do function test uint overflow protection. And I'm going to define two variables again, A and B. Say A is a type of U8, small one, and the maximum value you can store in 8 bits is 255, as we saw before. So now let's define B to be of the same type, but now this is only number 1. And now I'm gonna try to do an addition. A plus B, right? So if this has overflow protection, this code should panic, right? Like stop execution and raise the panic. So to verify that, I'm gonna use the attribute should panic. So if I run this test should pass because I should panic, and yes. So what it's saying is that it is preventing the value from overflowing by panicking, which is what you would expect, right? Otherwise, it will overflow and go all the way around. And it also has underflow protection. So let's see that as well. Maybe I can just copy this scenario. I can just say test you in underflow protection. And now let's do like this says it's 0 and it's 1. So if I do A minus B, it will try to make it negative, which is not supported by an unsigned integer. So it should panic. And it is panicking, so it is protecting against underflow. And also for the sake of completion, I can do this same example, but now with signed integers. So you know that it's also working with signed integers. So let's give it a try. Basic int math. And in this case, let's do, for example, instead of b minus a, let's do a minus b to get a negative number. And the rest, a minus b should be, oh, of course, should be I8, signed integers, right? This should work, no problem, yes. And you get the same benefit with underflow and overflow protection for signed integers. I can just simply, I'm not gonna duplicate this, but it's just, you can do it on your own. Just change the types and verify that it's actually doing the protection. Actually, maybe let's do it because the values are different to trigger the overflow and underflow. So let's start with this one. Let's call it just int overflow protection. So modify the types to signed integer. Because it's a signed integer, the maximum value you can put here is 127. It's not gonna hold 255. So if I try to go up one value, should overflow, right? So 128 doesn't fit in a signed integer. And in the case of the underflow, it will be just going more negative than allowed. Let's go I and I. So the minimum value for a signed integer is minus 128. So if I try to go one value lower, should fail as well and underflow, trigger the underflow and the protection with panic. So it's panicking, so it is protecting me. I also want to show you how to combine two different types, like unsigned integers and signed integers, into a single computation, because you're gonna force it to learn casting. Let's do this test. Let's go function test mixing types. This is a success scenario because I'm gonna show you another fail scenario. Let's see that A is actually an unsigned integer of value 3. And then let's have B to be a signed integer of 8 bits. And let's say that it's 5, right? So two different types, even though they have the same number of bits. Let's do an assertion of an operation. Let's say, for example, let's do A plus B. And this should in theory be 8, but this doesn't work because they are of the different type. So I cannot do this operation. I need to bring one type to the other. So I can turn, for example, this signed integer to unsigned integer by doing try into. It's a method. And then this method returns what's called an option, which is an enum, and I can unwrap that value to get the actual underlying value. This is very similar to what you found in Rust as well. So now I can actually do the operation. I can combine both because basically I'm turning B into an unsigned integer, so I can add it to the other unsigned integer. I can also, let me see how this actually would fail. Let me do another test scenario. And this one is mixing types fail. because you cannot always do this, right? Only in certain conditions you can turn one type into another if they actually fit. Let's say that A is U8 and its value 3. And now B is gonna be a signed integer as before, but let's say that it's -5, okay? And let's try to replicate this. I'm gonna just do the same thing. Of course, if I try to do a regular assertion and do A plus B, well, that is, A plus B would actually be -2, right? Because B is negative. But the types are different. So if I try to do the same trick, like try to convert this into an unsigned integer, this is not gonna work. Because you cannot put a -5 into an unsigned integer, right? This is gonna fail. What you could do is turn the unsigned integer into a signed integer, right? That's actually possible. So let's actually try on this side. A try into and unwrap, and this is now working because in that direction it's actually possible. Finally, I want to show you how to do more advanced math, because obviously you sometimes want to go beyond addition, subtraction. You want to do like raising to a certain power or finding the square root of a variable. That is not supported directly by the language, but you can use libraries in your project. And the library I want to show you is called, you can find libraries if you go to Scarb's XYZ. This is the registry for Cairo. So this one called Alexandria Math. And you can see that the latest one is 0.6.0, and you can, it's a set of math libraries and algorithms. So I can bring that into my project by simply going to my Scarb.toml, and in the dependencies, and looking at my reference, I can bring it Alexandria with the same name that you find it in the registry, and just define which version you want. 0.6.0, which is the latest one that we saw here. So that this will make it available in my project. And now I can bring it into scope by going at the top of the module. I bring it into scope by using the use keyword. So I bring the package, and then I'm gonna bring, I can do this. No, I have to do fast power. This is the one that I want to try to elevate to a certain power. So let's give it a try to this one, this function. Let's create a new test here. And let's call this one function test advanced math. And let's create a variable A. It's an unsigned integer 32, and it's value 4. So now I want to elevate to the power. I do a fast power of 2. So I pass A, I pass 2, and this should be equals to 16. Right? And it seems to be working. If I Scarb test, it's passing, right? It's doing the operation. I can do, for example, the square root as well. So I need to bring another function into scope from the same library. In this case will be use Alexandria Math. It is called square root. No, what's the name? The name is fast root. Fast root, and the name of the function is a squared fast square. Let's give it a try. And the way it works is you do an assertion. It's called fast square, and it is expecting to provide A, and you need to provide also this one. You have to check the documentation to see what it's expecting. But the thing is that the square root of 4 should be 2, but it is expecting this type to be of unsigned integer 128, and it's U32 in our case. So we need to do this conversion, try into and unwrap. And this is a method as well. So now this actually works, and it's all passing and working. Next topic on the agenda is casting. So let's, as usual, let's start by creating the file casting.cairo. define the module for our package, casting, same name. So we can work here. As usual, we start by defining our testing suite and the associated module, tests. So casting is a process to turning one type into another. And there's essentially two ways to do this, or two main type of casting, going from two types who are compatible with each other and trying to go from two types who are incompatible with each other. So let's take a look at some of the happy path. So let's create a new test here. And let's call this one test casting to bigger type. Casting to bigger type. So this is an easy one to do because it always works. Let's start with a variable a of type unsigned integer 8 that is a value 10. So now what I'm going to do is do an assertion. I want to compare a to the same number 10, but in this case of type u16, right? So obviously this doesn't work out of the box because there's a type incompatibility, u8 versus u16. So I need to turn this variable a to do a casting into unsigned integer 16. And this always works. Going from a small type to a bigger type always works because you can always fit a small value into a bigger bucket. And to do the casting, we've seen it before, we do the method try into, which returns an option, and you can unwrap the option to get the actual value, and you can see that now it's compatible, right? So we can do this test, and it should work, right? Working well. Okay, next scenario we want to test is casting to smaller type that fits. So let's try that test. Casting to smaller type that fits. So when you cast, you go, for example, let's go the opposite direction. Let's see, the a is unsigned integer of 16 bits and the value is 10. Now and do an assert that is different than before. I want to compare a to the same value but of a smaller type, u8. Okay. It's basically the opposing or the opposite casting that we had in the first test. And this is a little trickier because you're going to from a bigger type to a smaller type. So it's not guaranteed that will always work, but because this is a small value, we know that it's gonna fit, right? Because it's just 10, so we know that value 10 can fit into 8 bits. So this should work with no issue, with the same method, try into, and then unwrap, right? You can see it's working fine, mostly because it is a small value that we're working with. So if we run test, it passes. Let's go to trickier situations, and one of them is test casting to smaller type that overflows. Okay, this is also a common scenario. This is a little harder to manage. So let's see how it works. So I'm going from a bigger type, u16, and let's pick a big number, right? Because we are trying now to bring it down to a u8. But how do we do it? We have the issue that this value is too big to fit in a variable that only handles 8 bits. So if we try to do the if we try to do the conversion, for example, a try into, notice first that the value, what's happening here? Okay, we need to define the type, because what this returns, this method, is actually what I mentioned is an option. An option is a type of, it's an enum essentially that has 2 members. So the type is option, and inside the option is gonna be a value of type u8 only if the conversion succeeds. Okay, but an option can also return what is called none. It means that it was impossible to do the conversion, which is gonna be this case. It's impossible to convert. So we can check that it's actually impossible by calling the function in B is sum. Because an option could be the value or sum. It has two members. We're gonna see that we're gonna go to enums in more detail. But this is a way of testing actually is none. It means that it could not perform the conversion, so it returns a different member from this enum. And this is passing. If I try to test against is sum, this should fail. Okay, so it is none. So it could be sum or none. That's what the option actually does. And this fails because the value is too big to fit into onsite integer 8. Let's see another way to handle this same scenario, maybe a little more graceful. Let's, I'm just gonna copy the same name, save some time here. I'm just gonna suffix this with 1 and this with 2 because these are two ways of handle overflows. And we start with the same scenario, variable a value 1000. And I'm gonna try again to do the same conversion. So far so good. We know this is gonna fail, but we can do something a little more gracious. U8, we can say, for example, B, we can do the unwrap or, right? So you have the regular unwrap and the happy path. And this is the happy path or different value if a failure path, basically. So say, okay, if you cannot convert this into U8, which is gonna be the case, give me back a specific number. So I can say, for example, well, okay, give me just the biggest number you can fit in a U8. Maybe this is your decision. And now we can do some assertion to see this is working as expected. So C should be equals to 255 of type U8. And there's something here not working correctly. Let's see why. Condition has type expected boolean. Oh, because I'm missing one equal. So let's try again, run the test. It's passing. So we saw this method unwrap or, right? So you have the regular unwrap for happy path. You have the unwrap or that is able to handle fail cases more gracefully, but you have to provide the alternative value that will fit into U8. And then there's another way that you can handle this situation. Let's even copy this one more time. Now with the suffix 3, we start off the same way. Basically, we can do the same thing, but a little more compressed. For example, here, instead of going all the way to define the option like step by step, I can do it all in one step. I can say, you know what, B is going to be of U8, always. So I can chain here directly the unwrap or and pass the value. So in one line, I do the whole conversion. So now it's no longer an option. I know this is guaranteed to be onsite integer of 8. And now I can do the assertion, but this time with B. And it should work. Just a way to do all in one line, a little more concise. That's it. That's casting. That is the regular casting from small type to big type. It always works with unwrap. Then you got from big type to small type, but a small value that you know that it fits. You can do the same unwrap, no problem. The issue is going from big type to small type with a big value. You have to be mindful that the actual return value is an option, and you have some method like is none or is sum. This way you can test that it failed the conversion without actually failing or panicking the execution. You have this alternative method unwrap or to define an alternative value that should fit. Or you can do it all in one line, a bit more concise. Next on the list, we have, let's close this. Let's see on my notes, what do I have next? I have is result and option. So let's create a new file called result and option. And we saw that we worked with option already, but let's see the other enum called result. Let's bring it into module, result and option. And as usual, we start with CFG test and module tests. All right. Let's see. Let me define a couple of functions at the top. Let's write a function that if I pass a value, it's gonna tell me if it's even or not. And it's gonna use an option to symbol if it's even or not. So find or function find even. So this function is gonna expect one parameter, right? The value to be analyzed. And then it's gonna return an option, right? This is a type of enum that comes with the language. It's part of the prelude. So what I'm gonna do here is gonna do if the module of x is 2, I mean, if the remainder divided by 2, is 0, meaning that it's even, then I want you to return option sum. So this member of the enum, right? Member 1. But if it is not even, I want to return the other member of the option, which is none. Actually, it's not a method. Okay. So this way, I always return an option. It could be some or could be none. This is also very common in Rust as well, using enums. Let's try this out, this function. Let me check something. Actually, let me write another function that takes advantage of this, I think. Or no, actually, that actually uses result, because this is the option enum. Let me show the result enum as well, which is used for different purpose, but similar in the fact that it has 2 different members. It just allows you to define an explicit error message when it fails. So let's have a function called like divide. And this function is gonna expect 2 values. Let's say this, both of you 32. And then it's gonna return another type of enum that is called a result. Now result actually expect 2 different members. One is the actual result with a certain type, let's say U32, or it could be the error message. And now I'm gonna define the type of the error message, and I'm gonna use byte array. So let's implement this. So I'm gonna say that if b is equal to 0, right? So divided by 0 is not allowed. I'm gonna return the member error of the enum, and this one expects the actual error. For example, can divide by 0. Okay. I don't put semicolon because I want to actually return this member. Otherwise, if I'm trying to divide by any other number, perform the division and return the member OK, and do the integer division, because now it is possible to do. So again, this enum result has 2 members, error and OK. And in the error, you can define the actual error message. So 2 different situations when you want to use option when it's either a value or nothing or empty, and you use result when it's either a value or an error. Okay. So let's try them in our test suite. Let's bring these 2 functions into scope in the test suite using use, super, and asterisk. This is going 1 level up and bring everything you can find, put it into scope. So we can create a first test scenario, and this could be test divide by 0 should fail. Okay, let's test this scenario where I'm gonna call the function divide, let's say 10 divided by 0. I'm gonna capture this in a result, and you can see that automatically it's telling me that this is gonna be a type result U32 or byte array, right? It's able to read the return type and do the inference here. So let's do the assertion, because in this scenario, because we divided by 0, the result should be, there's a method to check that is error, right? This is the one should be triggered in this scenario because divide by 0. Let's take a look. And okay, seems to be failing as expected. Let me just modify this number just to see the error fail. Just make sure that it's being executed. Yes, it has been executed. Okay, good. So this is one way to verify that it's actually giving you back the member of error that we define here. Let's try another way to define this. Another test scenario. Function test, let's do, yeah, divide by 0 should fail, but this time we're going to use match statement. So just to differentiate this is using the method, the is error, and now I'm going to use the match statement. So same scenario. I'm going to basically duplicate this, put it here, and now I'm going to actually do a match. This is a way you can actually do some execution based on which member of the enum is being returned. So I'm going to match against the two options. It could be that is the result error, right? Member 1. And we know this comes with a value. This is a way to say, hey, pass me the error message in the body. I'm not going to use it. I'm actually ignoring the error for now. And in this case, I'm going to say assert true, right? This is the way to say, this is what should be happening in this scenario. This is what I'm doing with this assert true because I'm divided by 0. The other option, of course, could be that result could be of type of a member okay. I'm going to ignore whatever comes here. In this case, assert false because this should never happen, at least not in this scenario that I'm defining here, right? Because if for some reason we fall into this branch, this should fail the test. It should not come here. So let's try. Run the test. Yes, it is passing. So this is a way more fine-grained to handle both scenarios and do something with that. Third scenario that you can play with is basically how can you actually collect the error message? Actually, do I need to provide this here? Oh, yeah, I need to, even though, right, because the OK is returning the actual division. So I'm just basically just ignoring whatever is returning. That's what this underscore is doing here. So third scenario, test, this is gonna be test divide by 0 should fail. And now we're gonna match the actual error that is returned, right? Now we care about the error, not just if it's an error or not. So we start the same way as before, divide by 0. Let's do the same match here. But now, instead of just ignoring the error message, I'm actually going to collect the error message. Okay, pass me the error message, put in this variable. So now I can do an assertion that is more detailed. I can say, okay, I want the error. I want to check that the error is actually can't divide by 0, which is the error message we define here, right? Can't divide by 0. So we know exactly why it's failing. The other case is the same. We don't care too much. Let's see, let's give it a try. So this is a test of the actual error message, because if I modify this, if I put here the number 0, this should fail because this is not exactly the error message that has been returned. So again, you have more fine-grained control. Next. Okay, there is a shorthand version of how to handle this enum. So let me copy this scenario so I can show you. Let's duplicate scenario using fail. It's going to be fail shorthand. And the shorthand is basically you can remove the result and the language knows exactly that you're still referring to the result enum, right? It is implied. You don't have to define explicitly. So it works. And you can do the same as well in here in the definition. It also works. It understands that you're trying to work with the result enum, but I like to be explicit, so let's leave it in and then just leave the test like this so you have both examples. In the final testing scenario is divide by 0 match default. Okay, when you do a match statement, you can either match with every single option possible, or you can only match with the one you care about and then just have like a catch-all section for any other possible value. And you do that by essentially, let me define the test first. Function test divide by 0 should error match And now let's use the default. Default. That's correct. And we start the same way. And the match, I'm gonna copy the same match here. Just now, I don't really care about the error. I don't care about what happens here. So I'm just gonna put, this is like a catch-all again. Any other potential value coming from result, just catch it here. This is useful when you have an enum that has more than 2 members, let's say 5, and you only care about doing something specific about one of the members, and you do the same for all the others. This is how you use the match to cover that scenario. Run test. And it's working out. Okay. Then we continue when after, now we go more detail into enums actually. We saw the default enum with with option and result. Let's see how you can create your own enum. So let's create a file. Enums.cairo. We put it in a module. And let's bring my nodes. Enums. Okay. As usual, we start defining the test module. Okay. Now I'm gonna create an internal module because I'm gonna be doing almost like the same code, but with a small modification. So I don't want this code to like try to override what I wrote before. So to do that encapsulation, you can define internal modules just for code organization. So let's start with a simple enum. And the way you define that is by using the keyword enum. You give it a name, let's call it error, for example. And then you define all the potential members, right? So I want to handle, let's say, all the potential errors that my system can throw or can panic from. It could, it could be, for example, divide by 0, it's a type of error. It could be dividend smaller than divisor. Let's say that I don't want that to happen, so that's also an error. And then let's say inexact division, right? I can justify whatever error scenarios I want to come up with. So the way to use it, I can now define a function called divide. And let's say this function has a dividend of U32 and a divisor of the same type. And depending on the values that is passed, it is going to return a result. There's either going to be the division or an error. And notice that this error is now my enum. So it could fail by any of these 3 causes that I'm going to define. So we start, for example, if the divisor is 0, divisor is 0, I want this result, I want us to return, how do we do it here? Error or result, error. Let's do the shorthand. Error. And now which particular error? Let me have the full value. So which one of these 3 members I want to return as an error? It should be the first one, divide by 0. So I'm gonna bring my enum, then divide by 0. Okay. And I remove the semicolon because this is, I want this to be returned. Scenario number 2, if the divisor is bigger than the dividend, right? We know there is another scenario that we want to manage. So in this case, we're going to return a specific error, which is the one that we've defined as dividend smaller than divisor. Okay. And finally, we have that this third option, if the division is not exact, sorry. So the remainder is not 0. It means that the division is inexact. Dividend, the remainder, divisor, okay, this. So we want to return now is result error, and now the error message I want to return is going to be inexact division. Okay, so why do I have this error here? It's because I'm never even considering yet the actual value. So if at this point nothing has failed, it means that I can actually perform the division. Okay, so I can do result, so the OK branch, and now actually divide. Dividend divisor, and this is not working. Let me double check why. If blocks have incompatible types, result U32. Let's try to debug this. What is happening? This returns the value. I'm working with the three of them. What if I do just return, like explicit return? Okay, this seems to be working better. And this is failing because it's missing the semicolon. I wonder if that was missing before as well. Like if I remove all this, is this gonna fix it? No. Well, I'm surprised. I have to use the return statement explicitly. Don't know why, actually. Don't know why. If blocks have incompatible types. Okay, I guess I have to do it explicitly, but no idea why. So this seems to be working. And we can now have some tests to verify that these scenarios are the specific member of the enum has been returned based on the scenario. So let's have this test. And let's say that function test simple enum. In this case, I'm gonna do a division. Let's divide 10 by 2. And I'm gonna bring this to the result. Result, because you're going to be fixing with So what I'm going to do now is an assertion. Let's assert that the result, because 10 divided by 2 should fall into this scenario, right? Because I'm not dividing by 0, the divisor is not bigger than the dividend, and the division is exact. It's an integer division. So I should be able to get the OK branch of it. So this should be, the result should be equal to result OK. And the number 5, right? The return 10 divided by 2. Let's see what's happening, why this is not playing along. Try has no implementation in context. Oh, I see what's happening. Right. So when you define an enum, you're essentially defining a custom type. And any custom type doesn't know by default how to do comparisons, right? For example, I'm trying to compare two values, but my custom value doesn't know how to do this comparison. And what I have to do, I have to go to my enum and give it those abilities. And you do that by deriving traits. So the first trait that I want to derive, so it gets applied to my enum, is going to be partial EQ, right? This is for comparison. And the second, now it's happening variable not dropped, right? So the other thing that I need to teach my custom type to do is to actually get out of memory when it's not used anymore. That's called dropping. So I'm going to derive another trait called drop that is going to teach the compiler how to drop this from memory once it's not required. And now this seems to be working. So let's see, let's give it a try. Scarb test. It is working out. Again, we can use the shorthand version if you want to be more concise. It's going to work the same way. Cool. Let's go something a little bit more complex, because right now the members of my enum are just types itself. I just want also to have values for each one, the actual error message, for example. So let's create another module to group all these. And here, let's call it this module. I'm gonna call it Enums with values. And essentially, I'm gonna let's copy the same and just modify as we need it. So I'm gonna put this here, same enum, deriving the same traits, partial equality and drop. But now, when this member is actually going to have more information, I want this to return a struct, or yeah, a struct called divisor. So I can bring more information or return more information to the caller. And I want in exact division to bring back the remainder. So these are two new types I need to define. Type not found. Okay. So let's define first the divisor. And this is gonna be a struct. So a struct is a way to define multiple properties into a one type. And this is the key struct. Start with divisor. And this is gonna have two members, the dividend, U32, and the divisor, U32, right? So this type is now defined. So I can now, when I call this member, I can actually return a struct that has these two values defined. The remainder is gonna be simpler because it's just gonna be type U32, the remainder exactly. So an easier way to do this one is just a simple, like a translation of types. I can say the remainder, you know what, it's just a shorthand for U32. Those two things are the same. I'm just gonna give it a more descriptive name to it. When you define a custom struct, you also need to be aware of this. You need to teach how to do comparison and how to drop it from memory. So we apply the same thing. We don't have to do this here because the built-in data types already have these things applied, and this is just basically those two things are the same. We don't need to do this manually again. So let's try to use them again in a function called divide. And there's no collision because they live in different modules. So we start with the dividend, U32, the divisor, U32, and this is gonna return a result that is either the result of the division, or it's going to be the error enum that I just defined. So again, we start with the divisor. If it's equal to 0, we know as before, we're going to return an error. Now using the shorthand syntax. And I return the first member of the enum, which is just error divide by 0. Same as before, because we didn't modify this member. So nothing has changed so far. Let's go to this next scenario. Divisor is bigger than dividend. And in this case, we know this is going to be an error, right? And for example, I'm going to return this case error. It's going to be the error that is dividend smaller than divisor. But now it actually going to return a value that is going to be the struct, right? We need to use this struct and pass it here. So to define the struct, or to use the struct, we're going to define a variable called division, and of type, the type was called divisor. Division? Wait a second. Yeah, I have an error here. This should be division. All right, that's what I was not doing well. Division is of type division, the struct, and it's gonna have two values. Is equal to the struct division with two values, which is gonna be the dividend, which I'm gonna pass the value dividend, and then divisor. Basically return the same values that I'm passing to the function. And the member is the same name as the value. So in those cases, you can do a shorthand, just basically just define it once, and it knows what you're trying to do. It's just a shorthand version of it. And now I can pass this struct here, or this custom type, right? Because it is expecting to return something, and that something has to be of type division, which is a struct that I defined that has two properties, dividend and divisor. Good. Third scenario will be if the division it is not exact. If it's not an integer division, this means that the dividend, the remainder of the division, it is going to be different than 0, right? Divisor. So in that case, I'm also returning an error from the member inexact division, which expects a type to be dividend. Wait, the type, what was the type? Remainder. And remainder is just a shorthand for U32. So I can define it here. Let remainder is going to be of type remainder. And this is going to be the actual result division. So dividend modulo divisor, and this is what I return, remainder. This is not working. Why? Identifier not found. Remainder. Okay. Under the hood, this is just an U32, right? It's just I'm just giving it a more descriptive name, but this I might as well just say U32, and this should also work. I just try to keep it as the way that I define. And finally, if I don't follow any of these scenarios, the division is fine. I can just go ahead and return the OK member and actually perform the division. This is just the same way as before. Divisor. And this doesn't require semicolon, so it returns the value, or I can just keep it return so it's consistent with all the branches of my code. Let's write a test for this to make sure that it's working as expected. Test. Test function. Let's call this test enum with values. And the first test, of course, I'm gonna it's called divide 10 by 2, some happy path, right? Let's capture this in the result. There you go. And now I can do an assertion, right? So this scenario should actually go all the way down to the OK member. So that's what I should be getting. So the result should be OK with the value 5, right? So 10 divided by 4 is 5. I can do another scenario. Let's divide this by 0. In that case, we know we're gonna get a specific error message. So assert. So result should be, in this case, should be the member error of the result enum with a specific value, right? It should be the member of error divided by 0 that we define at the top. This doesn't have any value, it's just a type. Another scenario will be to have result divide, let's divide this 10 by 3. So it is an inexact division. So let's verify that we're getting into that member. Again, result should be equals to error, but in this case, the particular error message should be inexact division, and the value should be 1, right? The remainder of this division is 1, which is type remainder, which is type U32. It's all the same. We can make it more explicit, so remainder. So type remainder, and it's 1, and then put it here. Maybe it's more descriptive this way. And the final scenario we want to try out is when we actually have the divisor to be bigger than the dividend. So let's put here 4 and 10. And we know that's also going to trigger an error. But it's going to be the member Dividends more than divisor. And now, what is the exact value that should return? We can put it here. We can just create a struct. Let division be of type is a struct division, which should be dividend 4 divisor 10. That's correct, right? These two numbers. So this is what it's expecting here as the value return. Let's run the test, and everything is passing. So I just show you how to create just a custom enum that is just types. Remember that you have to give it some specific traits so it can do comparisons, like the quality comparison that we have in this test. We also need to teach it how to be dropped out of memory when it's not being used, that we're deriving the trait drop. And then we actually use it here in the dependent situation, and this is the test. But we can go one step further, and the enum can also have specific values returned by each of the members. For example, this one doesn't return any value, but this one returns a value that happens to be a custom struct called division that I need to also define how to compare, how to drop from memory, define the members, and then I can, if it's only just one value, I can just make like a shorthand, which is these two things are the same, but it's just more descriptive to use remainder, and now I can have more control about the values being returned. So this is just being more verbose way to handle your program. Okay, next step in the agenda is to talk about mutability. So let's create a new module. First of all, a new file. And let's call this one mutable.cairo. And as always, let's add it as a module. Mutable. There you go. And we start with our test suite. CFG test and the module. All right, first test I want to show you is just try to some basic mutability to see how it works. So test immutability. So something simple, let's try to define a variable u32 and start with some value, let's say 1. What if I try to modify the value? Let's say, for example, say a equals 2. And as you can see, this is not possible. This is causing an error, says cannot assign to an immutable variable. And that is because by default, every variable in Cairo is immutable unless we marked it otherwise. So I'm gonna just comment this cannot mutate. So you have it as a reference. I'm gonna comment this out. Let's try something different. Let's try now shadowing. What is shadowing? So we start again with some sample variable as before. And what I can do now is actually I can reassign the variable to something else, but I have to do that a redefinition. For example, if I want to, I can do a, now it's a u8 and the value is 2. And this is allowed because I'm not technically modifying the variable. What I'm doing is I create a new variable with the same name that is now shadowing what was defined before. So now this new definition is going to shadow the old one, right? So this one is just, it gets lost. So technically I'm not mutating, I'm just reassigning. And just to confirm that, I can do an assertion. Say, wait, if shadowing is working, the value of a at this point should be 2 of type u8. So let's give it a try. Scarb test. And wait, there's something here weird. There was like a warning. Unused variable. Oh, okay. Right. It doesn't like that. Say, okay, you're shadowing this variable, so why did you create it in the first place? So, you know, an easy way just to avoid the warning, just put a underscore in front of it, and it just stop complaining. Underscore just to signal to the compiler and to the linter that you know what you're doing by not using the variable. It's just for proving a point. And it should now work without a warning. There you go. All right. Next is actually, let's go back now. Let's talk about mutability, actually. How do we make a variable mutable? There's mutability. So let's, again, Same example, 32, let's say it's 1. So how do we make, we mentioned that by default every variable is immutable, but we can mark a variable as mutable, right? And we do that by the keyword mute. We put it ahead of the variable definition. So now with this keyword, I can say a equal to, right? And now it's allowed. And to prove it, I can do an assertion. So at this point, a should be 2 of type U32. And if you run the test, this should work, right? So compare these two. This, by default, if you don't define the mute keyword, the variable is immutable, so you cannot do this reassignment. You can do shadowing, but this is different. It's just reusing the same variable name for different purpose. But if you actually want to mutate the variable, you can define it as mute, and then now you can modify it anytime you want. And finally, let's talk about constants. New test case, function, test constants. And a constant is defined by the keyword const. Usually you use uppercase, this is just a convention. You have to always define the type, and you have to always assign a value. You cannot just leave, you cannot just declare a constant without a value. And what I mean is that you can do, let me just behind, you can do let be U32, and, oh no, actually you always have to define type as well, the value in both cases. But in any case, in the case of a constant, obviously you cannot modify the value for anything else, right? This is not allowed, it's never allowed, there's no mutability allowed for a constant. It is always the same. And just a final assertion, a equals 1 of type U32, right? So I mentioned I like to use the syntax mostly for testing, so I can compare to a specific type, not just the value, just to make the test more robust. There you have it. Immutability by default, shadowing, want to reuse the variable for something else, you can make it mutable with mute, and then you have constants that are always immutable, and there's no way to define it as mutable. Moving on, next on the list, what do we have? We have snapshots. All right, let's go close here. Let's create a new file. Snapshots plural, not Cairo. Let's add the module. All good. Back to the file. I'm gonna open my reference here on the side. Okay, as always, test and the module. Get started. Okay, I'm gonna define a struct, right? We did that in a previous section, and to define a struct is basically define a new type, a new complex type. Let's call this one person, okay? And my person is gonna have two properties. It's gonna have height, let's say that is U32, and it's gonna have age, U32. One thing I mentioned that when you define a custom type with a struct, you also need to implement some specific traits that the compiler will need. The most commonly required is the ability to drop the property from memory, and you do that with this attribute called derive, which it just implements a trait, and now my struct is able to be dropped when it gets out of the execution context. Let's create now a function that makes use of this struct. Let's say function get age, and this expects as an argument person of type person, the struct, and it's just basically it's going to extract the age from the struct, right? So let's say it needs to be U32 because that is the type we define for age. So how do we extract the value from the struct? Just basically you access with a dot person.age, and I don't put the semicolon, so it returns the value, right? This is just how do you access the member of a struct and return it. So far so good, nothing new here, we discussed this before. Let's do a few tests here. Test function. What I want to test here is this function get age. All right, so to test this function, I'm gonna create like a sample person using this new struct. Let's say person is of type, is going to be an instance of the struct person, and I'm going to provide the values that I want. Let's say that the height is 180, this is in centimeters, and the age says is 30, right? So this is the person defined with a semicolon. Okay, this is how you define an instance, or yeah, I like to sometimes refer to some JavaScript terms because it looks similar to like a class or an object, but it's just, this is a struct now with values. Let's now say that, let's try to extract the age by using the function. So let age is going to be U32. Let's call the function get age, and we're going to pass the person, right? The instance that we have. So if this is working fine, I should be able to get the value 30, right? So this property age should be 30. So let's verify that. So an assertion age should be equals to 30, right? Seems to be working just fine. Let's run this. And that's good. That is working. One thing, what about if I try to access the property directly, right? I should be able to do something like assert person.age, right? That this should be possible, but for some reason I'm not allowed to do it here, right? But what is happening here? It says variable was previously moved, and this is a concept that also you're gonna find in Rust, is that it's ownership. When you pass a property like this, like a complex type like this, what you're doing is not only passing the value, you're actually moving the ownership of this variable out of this context and into the context of the function. So now the ownership of this value exists only at the function level, and we never return this ownership, meaning that after this point on, we can no longer access the struct because the ownership was not returned. And just to prove it, let's comment this two out, right? So if I don't call the function, notice that I'm able to access the struct because I never moved the ownership. The ownership stayed in this function, the test get age. So that's something to keep in mind. Ownership. This is one of the reasons. This is done for some performance reason. For example, in Rust, this is what it allows languages like Rust or languages like Cairo to be as performance. But you need to be mindful of this property of ownership and how ownership is moved around. So in this case, ownership is moved, so you cannot do this. So let's put a comment here, ownership moved. So let's see how we can play with ownership a bit more. Let's define a new function that handles things a bit different. Let's call it get age, but now return ownership, right? Because that was an issue before. We were getting the ownership of the value, but never returning to the caller. So let's expect the person to be passed. But now I'm going to return not only the age, which is expected from the function as before, but I'm also going to return the ownership of the struct. Okay. So this is meaning that I'm returning a tuple that has two members, a value and a struct. And the way that I can return both things in a single command, I can define a tuple that's first member is the age, and the second is actually the property itself. This is basically returning the ownership back to the caller. So let's see if this is working as expected. I define my test, and let's call this function function get test get age return ownership. And let's do the same thing, right? I'm gonna define a struct now with some values from these structs, and it has some height. And let's have the same values, it doesn't matter. Age 30, right? So same as before. So now let's try to do the same thing. Let's try to call the function, but now this time let's capture the ownership back. So when I call the get age return ownership that we defined before, it is expecting only to be passed the person, right? But we know that it's returning two things, right? It's returning a tuple. So we need to capture the tuple here. So the tuple is going to be age, and the person is coming back. So, okay, so we have both things back, So now I should be able to do just like before. Obviously, that it was never an issue. I can read the age, and the age is 30. But now I can now also access the struct itself because the ownership was returned, right? So this is now allowed just because this function is taking care of returning the ownership. Let's verify, run the test. It's working well. It is though a little annoying, right? Verbose, like do I have to always remember to return? It looks kind of ugly, like what do I need? I only care about the age, but how do I make sure the ownership is returned? And well, we're gonna see some of that later on. For now, I just want to show you a different way to pass values without passing ownership, right? So that is one way to handle this situation. Like you want the value, but not the ownership. And let's create a new function. It's called get age with snapshot. And this is where the concept of snapshot is going to come into play, because now I'm going to expect a person, but it's not going to be just the actual struct. It's going to be a snapshot of the struct. This is what the symbol at is doing here. And what I'm returning now, I just return the value of age, right? So what happens is that at the time that the compiler passes the value of the struct to the function, instead of moving the ownership, it's going to create a snapshot in time, almost like a copy in time of what it was at that moment. So the function now is able to access the snapshot without actually having ownership of the struct, right? So I don't have to deal with returning ownership. The ownership remains at the caller level. The only downside is that now when I want to access a property of the snapshot, I need to do something called dereference, which is basically use this asterisk in front of it and person.age, right? This is how I enter the snapshot to get a value from it, and doing something very similar as before, but without taking ownership. So let's verify that how it works. The ownership part. So let's call this function test get age with snapshot, and let's do the same as before. I'm just gonna copy the same code, just gonna do it over and over. It's the same struct, right? It's just now, obviously, I'm gonna call this new function get age with snapshot. And remember, the function is not expecting the actual struct directly. It's not expecting the ownership, expecting the snapshot of it. So again, this is how I define the snapshot, and returns just the value, just the age, hu32. I can leave this out. It's gonna be able to infer the type. You can see this is the extension telling me, hey, this is what the compiler is inferring, which is correct. But I like to be explicit. And let's see if the ownership was never moved. So as always, age is never an issue. We can actually access it, but let's see if we can access the actual property directly. Person.age is equal to 30, and yes. So this confirms that the ownership of this struct remained at the caller function. It was never passed. It was never moved to the function because we only provided a snapshot of the value, not the value itself, not the ownership of the value itself. So remember, this is how you find. Just give me the snapshot, and you need to do this dereference of this. It's called this snapshot to be able to access properties of the struct. Okay, that is one way to handle this, and we're gonna see another way in the next section when we're gonna be talking about references, if I'm not mistaken. Let me see my notes. Yes, references. All right, let's create a new file. Let's call it references Cairo, new module, references. Okay, and I'm gonna open my notes, just basically following along the same repository that I shared with you with the final version of all this. Testing suite, CFG, test, the module, and let's start with, again, same struct as before, and the same struct is gonna have height, u32 is gonna have age, just as before, and we need to implement the drop trait, derive drop. Is this the same? Oh, this is square brackets. Okay, same as before, nothing new. Let me put a little bit of space here. Okay, let's create a function that is called make person older. Okay, and this function now, what's gonna do is gonna take the struct, and it's actually gonna try to mutate because it's gonna try to increase the age. And because this person is gonna try to mutate the value, we need to identify that or signal that with using the keyword mut, right? So give me the mutable version of person of type person. And I'm not gonna return anything because I'm gonna mutate the struct in place. So I'm just gonna increase the age by 1. So I'm gonna do is person.age plus equals 1. And I don't return the value, I just do the mutation in place. So let's see what's this is doing and how it works. Let's do a test. Let's call this test test take ownership. And in this test, we are going to, as always, create the person, an instance of it, with height 180 and age 30. And we're going to now call the function make person older, and we're going to pass the person. Okay. Now, what's happening here? Are we passing ownership again? And yes, basically we are still passing ownership. It's an ownership that allows you to mutate, but the ownership is never returned. We're back to the same issue, and we can see that if we try to access directly the property, it's not possible, right? It's gonna give us the same error. Hey, this was previously moved. It's not gonna work. So let's just mark this as ignore, just to leave it here, and let's just comment this up because this is gonna complain the compiler. So again, not even if you mark as mutable, it doesn't solve the ownership problem, and we know that we can tackle that with a snapshot in a way. Although a snapshot in this case is not gonna work because a snapshot is like a read-only version of the property. You cannot make modifications to the property because you have it in read-only mode. So how do you handle this ownership when you want to actually mutate the value, right? So this is what I'm trying to show you today. Let's create a new function that handles this better. It's called this make person older return ownership. Okay, a little bit verbose, but it's clear what it's trying to do. So same as before, it's going to expect a mutable version of the person. And now, because I want to return ownership, I'm going to return the same property back, or the same value person back. So ownership is returned to the caller. So I'm going to do the same as before. Just going to modify, going to mutate, increase the age by 1. But now I'm going to return person. Right? This is me returning ownership to the caller. So let's see if it's working. It should work, right? We saw this in the last section how this actually works. But let's see it again here. Function test return ownership. And just gonna copy because gonna have the same struct here. And now I'm gonna call the new function, right? It's gonna call the make person older return ownership. I pass the person, but I get back once again person. Notice that this is basically is doing shadowing, right? This is new. This ownership is being returned is shadowing whatever I defined before. So just also keep that in mind. This is some shadowing happening at the same time. So now if I do assert, if I try to assert macro, if I try to access the age directly, I should be able to do so because the ownership was returned from the caller. Although they should not be 30, it should be 31. So let's verify that because the function should have mutated. And yes, this failed because given the function the mutation, it should be 31. And that's correct. So we can see that the function actually mutated the value, but it was able to return ownership, and we're doing some shadowing here at the same time. Okay, now again, this is annoying. Like, do you have to always take scalar return ownership? Is there a shorthand version to do this, like some trick like a snapshot, but for mutation? And yes, there is some syntactic sugar to make this a little bit easier to manage. And I'm going to show you how with a third function called make person older with reference. In this case, I'm gonna expect the person, but now I'm not gonna return ownership because I'm gonna define this property or this argument as a reference with this keyword ref, okay? And what this keyword is doing is basically is returning ownership under the hood. So you don't have to do it manually, it's gonna do it automatically. So it's first of all, it's marking this as mutable, so you can modify this as you want, and it's also returning ownership all in one go. It's like a syntactic sugar, so you make this thing a little bit simpler, because now you can simply do person.age and then modify the age as before. You don't have to return anything explicitly. This is all now handled by the compiler for you. And to check that it's actually working, let's create the final test scenario for this section. Let's call test make person older with reference, because that's a function I'm testing here. And as usual, start with the same struct. I'm gonna copy here, and I'm gonna call the function make person older with reference. And the key here is now I'm not just gonna pass the person, right? Because this will move ownership, but that will be incompatible with the reference. It's expecting a reference. So to give it a reference, I need to put the keyword ref in front of it. Why is this complaining? Ref must be a mutable variable. Oh yeah, right. So the mutability is not defined at the reference level. We're gonna define it here directly when we define the value itself. So now we pass a mutable reference, so it's what allows us to mutate here. So that's something that I actually got wrong when explaining the first time. This mutable, we move it to the definition, but now what the reference is doing is that, notice that I don't have to capture any value back as before. It's just gonna be all implicit for me. And to prove it, let's try to access now person.age 31. You notice that it is allowing me, right? We know that ownership is here because this reference is taking care of implicitly returning ownership to the caller. So this should be working fine. Scarb test. Good. Final. So to summarize, you can pass. Close this. Okay. You can pass the argument as mutable and do whatever you want, but you're taking ownership. So if you want to return ownership manually, you have to then return back the same argument back to the caller, but you can do this in one step and implicitly, so you make the code more concise just by using reference. And even though you don't find anything here, it's actually returning ownership at the end of the function, but you need to first make sure that you make the argument or the variable mutable in the first place, and then you pass it as a reference, so you know that you retain ownership on the caller, even though ownership was temporarily passed to this function, but when it ended, it automatically returned ownership to the caller. So now you still have access to it. That's it. So you have snapshots for read-only without taking ownership, and you have reference for mutable and returning ownership. Next topic is going to be the copy trait. So new file, copy trait.cairo. Let's create a module, mod copy trait. All right, now I open my internal reference, copy trait. All good. Okay, testing suite, CFG, test. Oops, okay. And I'm gonna start with a simple function here. Let's call this function add one. Okay, and this function simply is gonna expect a single argument. Let's say that it's called x, and it's gonna just add one to it, right? So it's gonna return the same type, and what it does is just x plus one. That's it, right? Simple function. Let's try to run a test. Nothing here surprising, nothing new. Function test add one. And let's now define let x equals 1. And I'm gonna call the function add 1. I'm gonna pass x. And the question is, well, is this also taking ownership of the value are we gonna have the same issue that if I pass the ownership and I don't pass it back, do I get an error? Let's see. Let's capture this with a different variable to avoid the shadowing, just to make a point. Okay. The question is, can I still access X? Right? Because it could have been moved here and it was never returned. So let's see what happens. Let's try to do a couple of assertions. Say X should be 1 and Y should be 2. Apparently nothing is complaining, right? Somehow I was able to retain ownership of X, especially. Let's see, Scarb test. Yeah, so ownership was retained. It was never moved to add 1, even though based on what we saw in the previous section, ownership should have been moved, like what happened with the struct, right? So what happened here? Why did this work and it didn't work before? Well, the answer is that the low level or the built-in types like U32, they actually implement a trait that is called copy. And that trait, what it does is that when you pass the value as an argument to a function, instead of moving ownership, if that type implements the copy trait, what it's gonna do is gonna create a copy, and it's gonna pass ownership of a copy of the value, not ownership of the value itself. So this is why this ownership is never bothered, because it was never moved. What it was moved is a copy done on the fly and pass here, because implicitly or in the compiler, U32 and all the basic types implement the copy trait. And so let's see that now with the struct, right? Can we use this fact to our advantage? So let's go back to the person struct. Same height and age. And we know that the first trait that we need to implement here is obviously drop. So that hasn't changed. Still need that. But let's now also implement the copy trait. Okay? So that's a new trait that we're implementing for the same struct. Because we want to have something of this behavior, right? It makes our life easier if we can just pass a copy and not having to deal with ownership. And so would this work? Let's try again with the function getAge. Something similar that we did before. Expecting the person to be passed. And it's going to return just the age, nothing more. And we're not going to attempt to return ownership or doing anything of that sort. Just going to try to access the age and return that. Okay, so let's see what happens when we try to actually use the function with a trait implemented. So let's go function test get age, and let's create again one more time the struct with some values, wrong syntax, curly braces, height 180, age 30. And now let's call the function. Let's call getAge, and we pass person. So we can capture the age here, right? Because that's what's being returned with a single. And this is a U32. Sure, let's make it explicit. Why not? So let's see what happens. Let's see. Obviously, we should be no issue trying to access age. It's never was an issue. Yeah, fine. Can we access person? Do we still have ownership of that thing? Let's see, assert person.age equals 30. And voila, we still have ownership of person. And that's because the struct implements now the copy trait. So the compiler knows that whenever I'm passing that struct around to another function, it's not going to pass ownership. It's going to create a copy and pass the copy to the function. So the ownership remains at the caller, so we can do this, right? So you can see different ways to handle the ownership issue. You can pass a snapshot for read-only. You can use a reference to move ownership and return it right away. But you can also implement the copy trait, so you actually pass a copy of the value. So in this case, behave very similar to how a fundamental type like unsigned integers or signed integers behave with the compiler. Let's take a look at this issue now when it comes to mutability, right? Because if we create a function called increase age, and this function now expects a mutable version of person, so we can modify the age, and it's gonna do as before person.age plus equals 1. So let's see, how is the copy trait interfacing with this new situation where I want to mutate the value. So let's see, let's create a new test case. Let's call it function test increase age, and let's use the same struct. And now I'm gonna call the function increase age. I'm gonna pass person. So question is ownership being moved? Yes or no? Let's take a look. Assert person.age equals 30. Seems to be working fine. So copy is working, and this is why I didn't have to mark this property as mutable, because what I'm passing here is not this variable. It is a copy, and that copy we're making it mutable. Okay, this is why we don't have to define it here as we had to do before when we use references, because reference is actually moving ownership but then returning it back. Here I never move ownership, I just create a copy and make the copy mutable so I can do whatever I want. And notice actually it should be still 30, right? Because what I modified was the copy, not the actual value. So let's take a look at this. Let's run the test. And the test is passing because when I increment the value, it's not the value of the original variable, it's of the copy. So that's why it's still 30, even though it was increased here. So it's not that useful in this situation to make copies. So it's better to use references in that situation. But now you know how it works, right? That's in for copy trait. Let's see what's next. Let's talk more about trait more in general. Let's open here my reference trait, and let's create a file called trait Cairo. Create the module trait. Oops, wait. Not trait. Yes. Wait, what is complaining? Module file not found. Did I create this in the wrong place? Wait, where did I create the trait? Is here? Oh, I think it's module file. Oh, trait is a reserved identifier. Okay, let's make it plural. Let's make it plural to traits because it is a special keyword in the language, so I don't want to mess up with that. Okay, now it's working. And start with the test suite, CFG test, no tests, and let's go. Okay, I'm gonna do many different versions of the same thing, and to avoid having collision of names, I'm just gonna find internal modules just to have a clean separation between examples. Let's have this module called traits inside this test, traits. Okay, and in here I'm gonna define a new structure, new struct, and let's call this struct. Let's go beyond the person's goal. Let's define human. Okay, and the human is gonna have health. This is like for a game, right? We're finding like a character, human character has health, it has strength, it has intelligence, right? Imagine like I don't know, like an RPG game that you have these properties of the character. We know that we always should have the drop trait implemented. We can use the right for that. So this is a struct, health, strength, intelligence. Okay, let's define another character of our game, right? So let's see, this is like a Warcraft type of game, and let's define now an orc. Okay, so the orc is gonna have same properties. It's just gonna have different values. Let's copy the properties here, and let's actually make it that implements the drop trait, so we can drop it when it goes out of context. And okay, cool. We have two custom types, human and orc, same properties. They could be different, but just happen to be similar. Now I'm gonna define some behavior, right? Because properties, especially in a game, is only one aspect of a character. The character should be able to do things. What are the things that it could do? Well, you define that behavior with a trait. And let's define the human action as a trait. So the things that a human can do. And it could do, for example, I could create a new human, like a new character that of type human. So when I call it, it returns of this type. The trait only has like a signature, like definition of things, not the actual implementation. So you can create a new one. You can, for example, maybe train a human, and you can increase some of the stats. For example, if you train it, you can increase the strength. So because it's gonna be modifying the struct, this is gonna actually be a reference, right? Because you want to move ownerships, you can do modification and return ownership right away, all implicitly. In the case of a trait, you define this as self, okay? And the type of self is human. So because this is gonna be a trait for human, for the type human. So that's the way. It's always the same argument in the methods of a trait is always self. Especially when it modifies the actual element. And I can do, for example, maybe make it study, so it increases intelligence. So again, it's gonna modify a property. It's gonna be a reference of type human. All right. So that is the things that a human can do. But now let's describe how the human actually goes about and do these things, because right now it's just showing the capabilities of the not the player, the type of character. So to implement or to showcase how this implementation actually works, you define what's called an impl, the implementation, and the implementation has a name. Let's call it the human action impl, and for or of the trait human action, right? So implementations and traits go hand to hand. So now this is where I get to define the actual behavior behind these three methods. So in the case of new, for example, let's say new, let's define implementation. We know that it returns a human. So this interface has to comply with what they define here. Otherwise, this is not gonna work. The compiler is gonna complain. And what we do is basically we create a new human, use the struct, and we say, oh, you know what, a human is gonna have health of 100 by default. Maybe the strength is 20, it's not very strong, and intelligence is 20, right? This is like a default human. It has these characteristics. Okay, so we implemented the new, this is like what's called like a factory pattern. It is complaining here, we say, hey, you still have to implement two more methods, train and study, right? Because those methods are defined in human action, so we need to implement all of them. So let's go for the next one. Let's implement train, function train. And we know that train is going to expect to be pass a reference of the human. So let's define the same here. It's a reference, self, human. It doesn't return anything. So what does it do? Basically, we're going to take this, what it was passed, the struct, and we're going to increase the strength by 5, let's say. Let's say that's how much a human increases in strength every time it trains. And we can do the same thing for intelligence. Function intelligence is expect a reference of type human, and what this does is increases the intelligence. Let's say that increases by 5. Right? This is like designing a game. And why is this complaining? Rest self-intelligence. What is this? Human is not a very human action. Intelligence. Maybe I have misspelled. Oh, it's actually study. That's the name of the method, study, that increases intelligence. Okay, great. So we have we define the things that a human can do and how it actually does it, right? Let's do the same thing for the orc. We're still working on their game. So as we start with the trait, the orc action. So let's say the traits are going to be the same, right? The difference is that now this trait is not going to apply to human. It's going to apply to the type orc, okay? Because it's going to be the things that the orc can do. And now we need to do the implementation of this thing. So let me copy this and then just modify it based on what the orc will do. So I'm going to copy the same implementation, but now I'm going to change, like, this is going to be the orc org action implementation of the org action. This is the trait. And then when I call new, I create a new org, right? So this is gonna be an org. And let's say that in case of an org, like a default org is actually stronger, 50, but actually is stupid, 5, right? Compared to a human. But now, obviously, this whole thing's changed to org. This also changes to org. And when an org train, because this is stronger than a human, they actually increase more in the strength every time train. But every time they study, they don't get much better, only 1. So that's a win for the human. All right, we have our little game implemented with orgs and humans. So let's actually do something with it. Let's define some tests. So test number 1 that I want to define here is let's test the creation of the characters. Test create characters. Okay, so I'm going to create a characters. We know that we have this method called new that we could use. And the way to access the method of a trait directly, for example, if I want to create a human, let human equals to, I can access the trait human action and then the method like this, right? Let's put here the type human. And this is going to be calling obviously this function, which is going to return a new struct with these properties. Health, strength, and intelligence of 20. And let's do the same for the org. Type org, and this is going to be org action. Let's call the same factory pattern. Then we have a human in an org. So let's make them do the stuff. Let's make a human study. Right? This is one of the methods. This is how I access the method. And it is complaining because it says reference argument must be a mutable variable. And we saw it in the section when we discussed references. Every time you have a reference, like when we have here, it means that the underlying value has to be mutable. Otherwise, you cannot modify anything, right? So it means that we need to make the human mutable. So we can call this method a modified internal state of the thing. Same with the org. Actually, let's make the org now. Let's make a study. We compare the results of both. We have to make this mutable again. And let's test it. Let's do an assertion. Let's see. So if this worked correctly, now the human intelligence should have increased to, it was initially 20. Every time that is study increases by 5. And because I make a study once, it should be 25. But in the case of the org, the intelligence actually increases less, increases only by 1, as you can see here. And it starts with 5, so it should be only 6 if I make it study once. So let's check it out. Let's try it. And it's working, right? So this is an example of how do you actually use implement traits, implementations, and actually how you use them, right? You can have a factory pattern, and then you can access methods defined by the traits. And if the trait always the same property is usually a reference to the object you want to apply the trait onto, and then you have to make it mutable so you can make these internal modifications to its internal state. But this is how it works, right? This is like a simple game that you can now define using traits and implementations. Let's go one step further, and this is where I actually am going to define a different module, because I'm going to define again humans and orgs, but now maybe in a slightly different ways, because you can see some advantages. Let's define this module called generics. And I'm going to start with the same situation of having a human and an org with, I'm going to make it a little bit simpler this time. I'm going to just copy this too. I'm going to show you how to try to reuse some of the things so we don't have to rewrite everything every time from scratch. So the same two structures, but now I'm going to let's remove health for a moment for both of them. Okay, so this is now, there are simpler structs. I'm going to find now a trait, but I want this trait now to apply to both, because one issue that we had before is that if you notice the trait for human and the trait for orc, they're exactly the same. It's just applied to different types. They're both create a new one. They both train. They both study. What changes is the underlying type that is applied to. So the question is there a way to just write this once and apply to more than one type? And yes, it is possible, and that is using generics. That's what I want to show here. So I'm going to find a trait that I just call action, right? I'm going to leave out the specific type. But now I'm going to define a generic, and you define this with this type of angle brackets, right? It doesn't have to be T in particular. It could be anything you want. It's just T is a convention for generics. And I'm going to define the traits as before, right? So function is going to create a new one. But now that new thing that it's going to create, the actual type is going to be referenced to generic. Because the issue is that the idea is that I can use this trait for any type. It's just at the time that I use it, I can define to which type it's going to apply. So this T is the generic. So the generic type could be either human or could be orc. I can define that later on. And then the same for train. And train expects a reference of self, in this case of T. No longer I have to define the specific type, just a generic type. Same with study. Reference self of T. There you go. So now let's see how we can use this generic trait now with the implementations. So let's go again with the implementation, the human implementation. Now this is going to be an implementation of action, right? But now I define to which type in particular, right? So I provide the value for the generic. So this is going to replace the T. So now I have an action that applies only for human, right? It's just a way to make this more general. I have to implement the three things. So let's do it. Function new. This is going to return human. Right, because now this is an implementation only for human, which is a struct and should have a strength, and it says 20. This is a simpler struct in intelligence that says 20 as well. Okay, we need to implement the other tool, implement the train, and expect a reference of self. Now we pass the actual type, right? Because once we replace the generic with the specific type, we need to be consistent here. And similarly for self.strength plus equal, let's say that is 5 for human, and then for study ref self human, and it actually increments the intelligence by 5 as well. Okay, so let's go on the other side now. Let's implement this for org, but always using the same trait. So we have only one trait definition for both. So implementation of org action of action, but now the generic is going to be for org, so these org, and essentially it's going to be the same thing, just with different types and different values. So let me copy paste. So this is going to return an org. So the struct is an org, and let's say the values is 50 and 5. So stronger but dumber. And then you have here, this is for org. This is also for org. And as mentioned before, an org, when it trains, it gets stronger than the human, but it doesn't get as intelligent as the human would study. So let's make sure that it's working, right? The big unlock here is that now we only have the trait defined once, while before we had to implement 2 different traits separate, right? So this is what a generic allows you to do. So let's make sure that everything is working as it should. Test. Let's call this test. Test create characters. This is why I define 2 different modules, just because I'm using the same name. So otherwise they're gonna create a collision of names. So similar to before, I'm gonna create a human of type human using in this case, the implementation directly, and call new. Okay. Is this what I did before as well? Notice that before I was able to do it from the action, but because now which is the trait, these are the traits. But now because the trait is generic, I can do it directly from the implementation because now this one is actually specific for each one of them. Let's make it also mutable as before, and the same with the org. Let mute org, org, and this is coming from the org implementation. Is it called org impl? Oh, wait, this should be called org impl. All right, org impl, new, gives it the right type, and just as before, I'm making both, let's say, study. So human.study, and then I make the same for the org study, and then we do some assertions, right? So if this is working, so now the human.intelligence should be, as before, 25, and now the org intelligence should be, intelligence should be only 6. Let's check that this is working, and the test, and it's working. Okay, so all that I want to show you is not only how traits and implementation works, but also how generic works. So you can have a trait that applies to more than one type, and save some coding. Okay. Next, what do we have in the agenda? Let's talk about constraints. So let me save this file, close it, create a new file called constraints.cairo, which is going to be associated with traits and generics. And you're going to see how in a moment. Let's add the module constraints and opening my notes. Constraints there. Okay. This time, before I get into the test suite, I'm going to actually define the high-level structures for human and org. We're going to continue the same example of the game. So the struct for human, right? Let's make it a little bit different. This is going to be about health, as U32, and strength. Let's remove intelligence for now, just to make it simple. Strength U32. Okay, I always misspell. Yeah. Okay. And we know that we need to implement or derive the trait drop. So always important and required to have it for any custom type like struct. Let's do the same for org. And org. Okay, good. So now I'm going to define, I'm going to use the concept of generic, but now let's define more things than these two type of characters can actually do. Let's make it a little more complex in the sense that we're going to be able to sometimes have functions to access properties of these characters, maybe just to in read-only mode, or to modify some of the values, right? Because we learned from previous session that when you want to access complex types in read-only mode, you use a snapshot, and when you want to modify a complex type, you use a reference. So I'm going to show you this here. So let's create a trait action as before with a generic, so we can use it for both human and org. First one is going to be new, the factory pattern that returns a new either org or human. But then let's define get health, a new method. And because this method is a read-only, we are going to define that it's always self, the first argument, but this time it's going to be of a snapshot of D, not a reference, because we don't want to modify, you just want to read. And to read safely and not have to deal with ownership, right? When you define a snapshot, you don't pass ownership. That's why I have this ampersand here. It's going to return the health, which is U32. Let's another one for the other property, get strength. Self, it is a snapshot. This returns U32 because that is the type of strength. What else? We can have more complex methods. For example, we can have one that is called is alive. Like when we make them fight we want to know if they have died or not, right? And this is because this is read only, and we should read in values and just make it also a snapshot. In this case, we're going to return a boolean because he's either alive or he's dead. And then let's define the method that actually going to modify this struct. And for example, we had it before, right? Train, and because it's going to modify, this is going to be a reference of the type T of the self. And then we have, maybe let's have another one, new one, a heal. And same, it's going to modify the health. So it's a reference. And then we have maybe hurt, right? When they fight, they actually get hurt. It's going to also alter the strength or the health in this case. So that's why it's a reference. So I have it here organized by, this is the factory, this is the read-only methods, and these are the write methods, essentially. So let's have the implementation. Let's start with the implementation of the human. Implement human impl of action, and we now pass the type for the generic. This is for human. So we have to implement all these things. So I'm just gonna copy all these things. I'm gonna paste it here, and we can just replace this with the correct type. This is for human. This is for human. This is for, wait, can I? Yeah, human. And same here. This is for type human. Okay, but I have to now do the implementation. So when I create a new one, obviously it's a struct, and I define the two properties. Define the health. Let's say that they all start with 100 health, both orcs and humans, but we know the strength for the human is lower. It's just 20. And the case of get health, we just want to read the property, right? And if you remember from the snapshot, when you want to access the underlying value of a snapshot, you have to do like what's called the dsnap operator, this asterisk, and now you can access any property. So in this case, the health. Same here for strength, right? It's a snapshot. I have to dsnap first. So this is for strength, return the value. Now is alive is going to be a bit more interesting. Let me do that last after I implement train, heal, and hurt, so it makes more sense. For train, it's gonna be same as before. Actually, there's many is alive now, because is alive is just checking if the health is more than 0. Because if your health gets to 0, if it's 0 or less, you're dead, right? So because this is a snapshot, I want to access health. So dsnap self.health. If this is more than 0, then you are alive, right? So this is true or false. So it's alive implemented. So now training, right? We know that training is basically self.strength, and then you increment that in the case of a human by 5. But if the character is dead, then it doesn't make sense. You cannot just increase your strength if you're dead, right? So they say this only gonna apply if you're alive, essentially. Otherwise, you're dead. You cannot just get stronger in the afterworld. Same, we can do the same for heal and for hurt. So in the case of heal, let's say the same. You can only heal if you're alive, so that's a precondition. And when you heal, in the case of a human, let's say that it's gonna heal, self.health property. We're gonna increase that by 10, right? This is what you like. This, you take a potion, something, and then you heal for the human. Now for her, this is the fighting mechanism. So we can do something like, let's see how we handle this. If you get hurt, meaning that if your health is more than 10, actually, I don't need to call the method directly. I can just, for example, call the property. Let me see. Get health. I can either call the method here, or I could call the property directly like this. Actually, you wouldn't even need to do this snap. Let's do it directly. There's no need to call here self.health. Okay, so if you have more than 10 of health and you get hurt, then it means that you actually is going to decrease your health by 10. Okay. But if you are actually, if your health is 10 or less and you get hurt, you die, right? Self.health goes to 0. Nothing else, you're dead. So next time you check is alive, it's gonna be 0. That is for the human. We can do the same thing for the orc. I'm gonna copy the same thing and then just modify where it makes sense. So this is gonna be the orc implementation, orc of type orc. So we modify all the references to human with orc. Okay. And when we create a new orc, it has the same health. They all start with 100, but it's gonna be stronger, 50. Get health, get strength is the same, is alive is the same, it's just reading values. But now train and heal is going to be different. We mentioned that when an orc train, it gets actually stronger. So it goes to 10. But maybe when it heals, it doesn't heal as well because they don't have as good medicine, so only 5. The battle mechanism is going to be the same. When you get hurt, you lose 10 points and you die if you have less than 10. So let's try out, let's test now our new advanced game mechanics. So let's create now our testing suite. CFG, tests, mod, tests. And in here, now I'm gonna bring into scope everything that I created before. So use super. So bring everything on top in this module. So let's create now, let's do a fight. Let's create a function that does like a human versus human fight. How this is gonna play out. Because a human versus human, you need to pass as arguments 2 different humans, right? And you have to pass it as a reference because you want to modify, because when they get hurt, you modify the internal state. So let's call it this human 1, and it's of type human, and then you have human 2, also of type human. But those are 2 different people. And we're gonna use the enum result that we saw before. And that enum is gonna say, okay, you either are gonna work and I don't return anything, it worked, nothing to complain, or it's gonna fail with an error, and this error is gonna be defined as a byte array, like a string with no limit in size. So let's see how it works. Let's first check if they are alive, right? Because if you're gonna have a fight if one of them is dead. So let's say if human 1 is alive, right? Let's say if human 1 is not alive, meaning it's dead, or human 2 is also not alive, meaning at least one of them is dead, you cannot have a fight. So you have to exit this function with an error. So you're gonna return the result, in this case with the error branch, and we're gonna find what error is. So one of the opponents is already dead, right? You cannot have a fight. So we are returning in this side of the result, right, with an error. Okay, that's condition 1. But if both of them are alive, now we can have a fight. And the first thing to check is which one of the humans is the strongest, right? Because the strongest one is going to be able to inflict damage on the weakest one. So let's check. If human 1, if the strength of human 1 is the same as the strength of human 2, right? They're exactly the same strength. Strength. So what happens in the scenario if they're the same? So they're both gonna get hurt, right? It's like a punching at the same time. So let's call this human 1. You're gonna get hurt. It's hurt function. And human 2 also gonna get hurt. All right, that's when they're all the same. But it could happen that maybe human 1 the strength is bigger than the strength of human 2. So in that scenario, the one that is going to get hurt is human 2, the weakest one. Hurt. Human 1 doesn't get hurt. So preserve its health. But in the other scenario is that actually human 2 is the stronger. So in that now it's human 1, the one getting hurt. So this is like our game engine defined here directly with Cairo. So if this is here, and so if I get to this point, meaning that the function returned successfully, right? There was no error. And to show that, I can say, okay, return the result enum in the OK version and with an empty tuple, right? This is the way that I signal that this function finished successfully with no error. Okay, that function is done. So let's do some testing. Let's try it out. Let's try our game engine. This is a little game that we're doing with testing. So let's say function test human versus human fight. So let's pass. Yeah. Okay, let's create 2 humans. Let's call one Edric, like I don't know, medieval humans. Edric is of type human. Because they're gonna be fighting and doing stuff, I'm gonna find them as mutable. So this comes from the human implementation. So I'm gonna create a new one. Then I create another human, also with a medieval sounding name, Alaric. Another human. Also, it's a factory pattern. There you go. Have the humans. So now it's time to make them fight. So let's call the function human versus human fight. And I have to pass both of them. I pass the reference because I want to pass ownership and then return ownership implicitly for Edric and also for Alaric. But to know what's going to be the outcome of this fight, well, I remember that this is a result that is being returned, and a result is an enum, and every time you have an enum, you can do a match. So this one way to test it out. Let's do a match on the result of this value, because this could either go well, like the function executed correctly, so I enter this branch of being okay with the empty tuple. And if this happens, so let's see how the fight turned out to be. So let's do some assertions. So if this happens, because we didn't modify the humans at all, they should have the same strength. So when they fight, both of them should have got hurt here. So the health should be decreased by 10. So let's see. Let's go to Edric, get health, and this should be now 90, right? It got hurt, so it lost 10 points. But the same should be happening with the other guy, with Alaric. Alaric, get health, should also be 90, right? And they both should still be alive, right? Because the health is still more than 0. So let's verify that as well. So both Edric is alive. They should be true. And the same for Alaric is alive. Should be true as well. Let's see. Let's now run our test to see if it's working. And yes, our game engine is working as expected, but we also have to consider that this could fail, right? Maybe one of them is dead. So if that happens, we need to take into account the other side of the enum. In this case, give me the error message, because if this fails, it means that something's wrong, right? Because it should not fail, because they're both alive, they both have plenty of health, so we should never get to this point. Just to make sure that is the case, we do this assert false. Okay, so we should say we should never get to this point. If we do, the test is basically failing. Okay, so what issue do we have? We have implemented all these like game engine, but we only have human versus human fight, right? what if we want human versus orc, or orc versus orc, or maybe orc versus human, or all the possible combinations? Right now we will have to write one function for each one of those combinations, and that will be super annoying, right? Because you have to manually find all the types, and just a lot of repetition. So how do we make this generic so we can have any type of fight in any combination? Well, we're going to use a mix of generics and constraints. So let me show you how that will work. Let's create a new function. It's called fight, and this function is gonna, let's start here first. Now I'm gonna call this opponent1 without defining the type, opponent1, and we're gonna have ref of opponent2. The question is, okay, what is the type? If this is generic, how do we handle that? Well, as the name implies, this is gonna be a generic type, but this is gonna be potentially of two different types. So that's why T1 and T2. And every time you define generics, you have to use the angle brackets and define the two potential generics in your system. So now opponent1 could be either human, could be orc, and opponent2 could be also either human or orc, more generic. And the result is going to be the same. It will return a result enum that is either success with an empty tuple or an error with a description of what happened. Okay, so now we can have something similar as before. Let me check my example. Yeah, I'm gonna have the same code as before. It's just now I'm gonna replace human with opponent, and let's see if this works. Let's start small. Let's start just with this function. I'm gonna put it here. You're gonna say, you know what? It's not human anymore. It's opponent. Opponent1 and opponent2, and okay, this seems to be working fine. Let's go with the next step. Is what if they have the same strength, right? What happens here? So now it's no longer human. It's actually opponent1 versus, let me just modify all the human references, opponent. Okay, this seems to be working. All right, next step. What if they have this, one of them is stronger than the other one? And let's replace again human with opponent. Finally, if everything goes well and I get to the end, I return the OK branch of the result. So the enum is all good. Now, is this gonna work out? Well, apparently now it's a generic function. So let's give it a try. Let's test it. Test function test fight. So let's now, for example, let's have a human versus orc fight. Let's call it as Edric, which is a human, and we bring this from the human impl as before. Give me a new one, and then we have, let's say, an orc named Gorbak, and this guy is an orc. So this is going to be constructed by the orc implementation with the factory pattern, right? So let's have them fight now. So I'm going to call the fight function, and I'm going to pass Edric on one side, a human, and another part I'm going to pass the orc, Gorbak. Okay. So now we need to catch the result, right? So we do a match just like before. You see, well, this could be end well, like maybe the function executes with no problem, and we get an empty tuple. And what happened here? So some of the assertions that we're gonna do, first of all, if this worked well, assertion number 1 will be that the human Edric, his health should have gone down, right? Because a human is weaker, so it should Edric the one that got hurt. Because on the other hand, Gorbak should still be healthy, 100%. but both of them should still be alive, right? Because losing 10 of strength or of health, it doesn't mean that you're dead. So Edric should still be is alive. That should be true. And the same for the orc. Gorbag is alive. Should also be true. And we need to take into account that this could fail in some scenario, but not in this test, because if it happens to fail in this test, this test should fail. This should not happen in this scenario that we're defining here. So let's see, let's run the test now. What's going to happen now? It is working as expected. Okay, so now we have a more generic function that you can pass either human or orc, so you can have all the combinations all in a single function. One thing I wanted to show you that I'm surprised that the compiler didn't complain at all. This is because this seems to be an improvement on the compiler for version 2.12 that I'm using, because when I prepared this course, it was the previous version of the compiler, 2.11.4. It requires you to be more specific about the traits that these types have, and that was the type constraint. So this is a good thing. This is actually simpler than I was ready to show you today. So I'm not going to try to even show you the old syntax, because I can see that it's not needed anymore, and that is a plus. So kudos to the Starware team for making it a better compiler. We are going to now the last section of the course, which is going to be arrays. So let's create a new file called arrays, called Cairo. Let's create a module. And arrays. Okay, so this is going to be a short one. And we start always with the CFG test mod tests. And let's write the first test right away. Let's call this test array macro. So the simplest way to create an array is to use the syntax, to use a macro that's called array, and then you pass the values 1, 2, 3, right? If you want to capture this in a variable, we can move it. Let's say it's called array or R, and let's define the type. I'm gonna say, okay, this is gonna be an array of on-site integers 8, right? You can define with a generic, which is the type of each one of the values here. Let's say this is U8. And let's use it. So if you want to add a new value to the array, I want to modify, and before I do that, I need to make it mutable. Otherwise, I won't be able to add new things. You call the method append, right? And let's append the number 4 at the end of the array. And if you want to remove something from the array, you can do array.pop front. So this remove it from the front of the array. And let's capture the removed value. So when you remove it, you actually capture it. So removed value. And the type of this thing is going to be an option, because this could either succeed or return nothing, be a none. It's going to be an option of type U8. Okay. Okay. So this is how you remove from the front. You can also, if you want to read of a specific value, just give me the value at a specific index. You can use this syntax, array at, and then you find which index. And let's capture this. This is the first value, and this is of type U8. So this is how you access a value of the array. And finally, what am I doing here? This is another way to extract a value from the array. Let test value equal to again array dot get, let me get 0. This one is going to return an option that you want to unwrap, and then you want to unbox. This is a more complex way to handle it. u8. So make sure that this all is working fine. We can do some assertions, see that the value returns what we expect. So because we started with 3, we added 1, but then removed 1, the total length of the array at the end should be 3. So array.length should be 3. Okay, that is test number 1. Test number 2 we want to do is that the value I removed from the front, because from the front means from this, should be 1. And this returns an option. So I would say, okay, the removed value should be of type sum1. Remember, option could be sum or none. That's why I'm doing this comparison with sum. And another test we can do is assert that the first value, in this case, the one that we capture here, because we removed this from the front, we did the pop front, this now becomes the first value here in index 0. So it should be 2 at this point, right? Finally, the other way to access the same value with a different syntax will be test value. And test value should be the same as 2. So let's try it out, run the test. This is working, right? So this is how you see some basic operations on an array. At this point, this trade is an option of a box. Okay, this is where you have the unbox. It's an option of a box. It's a more advanced type. How do you actually add an array? Let's take a look. Define a new function called add array. So what I want to do is just, if I give you an array, I'm gonna take all of the internal elements of the array and I'm just gonna add them together and give you a single number at the end. So I'm gonna expect an array to be passed as the argument. But is this a type array of 8? Like, how do I define this? The thing is, what I want to do, I don't want to modify the actual array that is being passed. I don't want to take ownership. Because I just want to do some calculation and return a value. So in the case of array, when you want to pass something like a similar to a snapshot, right? So like a read-only version of the array, you do that what's called a span. This is like a read-only version of the array, right? And you use it when you want to do some calculation without modifying the internal value. And at the end, I'm going to return the addition of all these numbers. So let's start with a accumulator. Let's call it the sum. And this is of type u8. It's gonna start at 0. Right? This is my accumulator. And now I'm gonna iterate over all the items in the array. And to iterate, I can use the for syntax, like a for I in. So let's go from 0 to from the length to the array. Right, so this is how the for is going from 0 to length of array. And then for each one of them, I'm just gonna increase my accumulator with the current value of the array. So array add I. Array. Right, so whoops, what did I do? Sorry. Array add what? So this is the syntax that we saw right here. Right? This is how you read in an easy way the value of the array while you iterate over it. And at the end, when you finish the for, just return the accumulator. So let's see how to use it. Let's write a test. Function, it's called test array iterate. And let's define the array. It's gonna be of type array u8. I don't need to make it mutable because I'm not gonna change the array. I'm just gonna access it. And let's create the array with a macro. Let's say the simple 1, 2, 3. So if I pass it to the function, let sum u8 add array, what I should get is of type u8. And what I want to pass is not the array itself because I don't want to move ownership. I just want to create a span, which is like a read-only version of the array. And you do that by calling the function, the method span, right? So it correlates with this. And so if this is working, the assertion should be that sum is equal to 6. let's give it a try. And it's working as expected. And with that, we covered all the topics for this session, which was very long, but hopefully you got some value out of it. So I see you all in the next session. Goodbye.